Conor Conway, and today I'll be speaking to you on the toxic effects of a commercially available herbicide, Roundup, on freshwater shrimp, Gammarus. So the aims are on screen. So the first aim is to investigate the toxic effect of herbicide at different concentrations on the freshwater shrimp, and our second aim is to calculate LT50 and 24LC50, which are parameters commonly used in toxicology studies as a measure of toxicity. So the LT50 is used to calculate the time at which 50% of the freshwater shrimp population die, and the 24LC50 is used to calculate the concentration of herbicide at which 50% of the population die after 24 hours. My hypothesis for this experiment is the concentrations examined in this experiment won't have a lethal effect on the freshwater shrimp. The first part of the methods that we carried out were the dilutions of the Roundup. Here you can see me getting the 100% Roundup from the fume hood. The reason it's in the fume hood is because the fumes, they can be toxic in high concentrations, so they were poured into a glass beaker and then they were diluted from there. The next ingredient that we needed to carry out the dilutions was the distilled water. Before carrying out the dilutions, the volumetric flasks were labelled from 0 to 20% concentration. The next part of our methods was to carry out the dilutions. In this case, I'll use the 20% dilution as an example. So 20 mils of 100% Roundup was poured into the conical flask. The contents of the conical flask was then poured into a 100 milliliter volumetric flask, ensuring that all the Roundup was transferred. We then added 80 mils of distilled water to make it up to the 100 milliliter mark. Once it was made up to the mark, the cap was replaced on the volumetric flask and was inverted to ensure that we get a homogeneous solution. The same process was carried out for the 10% and the 5% dilutions using 10 millimeters and 5 milliliters of the Roundup. To make our 1% and 0.5% dilutions, we used the serial dilution method. For 1%, we used 5 mils of our 20% solution, and it was poured into a 100 milliliter volumetric flask, and 95 mils of distilled water was added. It was then inverted to make homogeneous. We labelled the petri dishes with the different percentages of solution we're going to add to each one. The Gammarus will then be added to these petri dishes. So here we can see Killian collecting the Gammarus. 10 Gammarus needed to be obtained from the trays within the lab for each petri dish, for a total of 60 Gammarus. The Gammarus were caught using a variety of methods, from the use of a spoon down to a sieve. The shrimp were then placed in river water until testing was ready to begin. At this point, we were ready to run our experiment. To ensure that our solutions didn't get further diluted by the river water, the Gammarus were removed from the river water using a sieve. 10 Gammarus were then placed into each of the 6 petri dishes. The concentrations labelled on the petri dish was matched up with the solutions in the volumetric flasks. Dara then poured the solutions into the petri dish with the Gammarus, ensuring that the Gammarus were covered by the solutions. The lids were then replaced on the petri dishes and they were placed into the tray. A stopwatch was started at this point. Every 10 minutes, Maria went back to check how many Gammarus were alive in our 20% solution and in our control. The numbers were recorded and they will be used in our LT50 calculations, where we will determine at what time 50% of the Gammarus population died. After 24 hours, we went back to the lab to see how many of our Gammarus were still alive in the different solutions. The numbers were recorded to be used in our 24 LC50 calculations, where we will determine at what concentration will kill 50% of the Gammarus population after 24 hours. The following is a spreadsheet showing our results. After 10 minutes, we can see that 6 Gammarus are alive in our 20% solution and 10 alive in our control. And again, after 20 minutes, there are 0 alive in our 20% solution and still 10 alive in our control. These figures were used to calculate our LT50 value. So the number alive was converted into percentage mortality using the formula on screen. The percentage mortality values were then plotted against our times to get the graph displayed. A trend line was drawn between the 2 points. We then went to 50% mortality on our y-axis and drew a line across until it hit our trend line, and where it hit the trend line we drew a line down to the time values on our x-axis. This showed us that 50% of our shrimp died in the 20%. So here we have another spreadsheet showing the results of our 24 LC50 experiment. After the 24 hours were up, the number of Gammaruses were counted in each petri dish. Unfortunately, all of the shrimp had died in each of the petri dishes, excluding the control, where all 10 were still alive. The number of alive values were converted to percentage mortality using the formula on screen. We then had to transform our concentration values using the natural log. The logged concentration values were plotted against the percentage mortality values to produce the graph on screen. However, as all of our shrimp had died, we could not get a 24 LC50 value at the concentrations used. To obtain a value for 24 LC50, we would have to rerun the experiment with the lower concentrations of the herbicide. Then we would be able to find out the concentration at which 50% of the Gammarus died after 24 hours.
Okay, so in conclusion, we have 3 questions to answer. Our first question is, what do your results indicate with regards to the toxic effect of the herbicide on Gammarus? So our results clearly show that Roundup is an extremely toxic herbicide. From our LT50 calculations, we can see that 50% of our Gammarus died within just 12 minutes of being introduced to the 20% solution. What's even more shocking is when we look at our 24 LC50 calculations, where none of the Gammarus survived after 24 hours in any of the Roundup solutions, even when it was as little as 0.5%. These 2 statistics combined to show the lethal effect of Roundup on Gammarus, and therefore we can infer that it is extremely toxic to other marine organisms also. Our second question is, what are the implications of using a herbicide like Roundup near Irish watercourses? And to this I would say that using Roundup near Irish watercourses could be detrimental to the organisms within the system. As we have concluded, even in such small dosages as 0.5%, the Roundup has a lethal effect on the Gammarus. If the Roundup was to make its way into the waterway, it could destroy the aquatic organisms, plants and animals included, and this level of destruction could take years, possibly even decades, to recover. Our final question is to make a recommendation on the future use of Roundup along Irish waterways, and to this I would strongly suggest using Roundup only during periods of very dry weather, so that the rainwater runoff would not seep into the waterways and carry the Roundup with it. What I would further suggest is that the herbicide be only used when heavily diluted, and possibly only be sold in its diluted form. Finally, to address our hypothesis in the beginning, we said the concentrations of Roundup used in the experiment won't have a lethal effect on the shrimp, and I think it is fair to say that it clearly does have a lethal effect on the shrimp. So I hope that you enjoyed my presentation, and I hope that you found it eye-opening to the lethal effects of commonly used herbicides can have on the environment.